I'm Anil Kumar, and in this video we will summarize whatever we have learned about direct and partial variation, right? So let me write down direct variation on left side and partial variation on the left, right. Graphically, if you have a graph of both, then it's kind of simpler to see and make a decision. For partial variation, it does not start with origin. It's a straight line which goes through any other point but origin. For direct variation, it has to go through origin, right? So that is very important to understand. It is also important to understand that these lines could be going positive or they could also be going negative, right? So it could also be a case like this. However, the most important thing is that it has to go through the origin, correct? Here also, it could go in this fashion also. That's fine. This is also partial variation, right? Now let's get back to, this is the graph, where this will be the independent variable x and that's the dependent variable y. Now as far as algebraic equation is concerned, these two variables are related by y equals to kx, where k is a constant, which could always be calculated by ratio of y and x, right? Rearranged to get the value of k. Here, y equals to mx plus b, where m is the rate of change and b is y-intercept. By y-intercept, I mean wherever the graph crosses y-axis and b is not equal to 0. That is kind of important to understand. If b is 0, then it is no more a partial variation, it becomes a direct variation, correct? Value of k could be negative. If k is negative, then we have a slope which is going downwards, right? So this really indicates that k is less than 0, and that indicates that k is greater than 0. Perfect. So this is base of direct and partial variation. Now many examples which lead to such situations could be, for example, if you say cost, so cost for items, let's say cost C equals to number of shares N into the price, right? So here we have a direct variation. On the other hand, the cost could also be a fixed cost. Let's say you're going to a banquet and then there could be a rate for each person. For example, for each person you could cost $25, 25p, right? So that kind of an equation gives you partial variation. And this kind of variation gives you direct variation. If you are given points, then also it's easy to find whether it belongs to direct variation or not. Let's say we have a point 25 on any line, right? That really means that the value of k is y over x. That means 5 over 2. Now if I have another point here whose, let's say, x value is 4, then what should be y value? Figure it out. Okay? Now in this case, if I have a 0.25, then we have a fixed cost. So if I double 2, I need not double 5. It could be different. Do you understand? It could even be 7. Do you understand? In this case, however, if I double x value, then the y value has to be double, so that y value should be 10. Now you can check. If y is also doubled, then k here will be 10 divided by 4, and that gives you 5 over 2, the same value of k. In this particular case, when I double x value, the y value is not doubled. So that leads to partial variation, and this is a check which we'll be using in many of our examples and which you can also apply in many multiple choice questions. I'm Anil Kumar, and I hope these tips will help you to understand this unit on direct and partial variation. Thanks for watching. Feel free to post questions and subscribe to my videos. Thank you.